Yo, lads. Howdy ho. Hello, everyone. Hope you guys are doing well. Had a great weekend. You let me know. Can you guys hear me? Everything is going fine. Is everything good? Ready for Rumble? Yo, Shriram, what's up, bro? How you doing, brother? Is my audio okay? Okay. Is my audio fine? You guys can hear me fine? Or no? Before we get started, I just want to make sure. Should be, right? Okay, you can hear me? That's good then. Okay, cheers. Let's go. Yeah. Love the energy. Hell yeah. Okay. So today we are going to cover task 5, 6, and 7 to complete our networking concepts. So, yeah, there is nothing much to introduce about this because you guys have been with me for last 2-3 days. So let's get started with UDP and TCP, right? But before that, remember, hopefully you guys remember all the 7 layers of the OSI and basically the 5 from the TCP IP: physical one, the cables, data link, MAC address, network layer, TCP, IP address, transport layer is TCP, session, presentation, session with our session, let's say if we are doing a call or whatever, presentation layer, an application layer with the HTTP and all those stuff, right? Then we have the TCP IP model, in which basically the application layer, presentation layer, and session layer are part of the application layer. Transport layer, network layer becomes internet, data link. Physical, there is no proper there. I think it's part of the second one itself. Okay, so UDP and TCP. The IP protocol allows you to reach a destination host on the network. Basically, IP protocol or IP address helps in the transferring of the packets from one computer to another. The host is identified by its IP addresses. We need protocols that would enable processes on networked hosts to communicate with each other. So basically, we need like some methods, some software, so that the process of networking, where one host can talk to another, right? We need those processes and or protocols, if you may. There are two main transportation protocols to achieve this communication. One is UDP, user datagram protocol, is the connectionless protocol, right? Basically, you need to understand it's a connectionless protocol. Um, Not that there is no like with the connection, right? UDP does not require a connection to be established. UDP is a suitable for protocol. So what does that mean? I will give you some good examples, and then we have the TCP one, which is a connection one, right? A three-way handshake happens, which is very important to remember with TCP. There is connection oriented, but three-way handshake is the main one here. To give you guys a easy sample of right what UDP and TCP is, right? There's a meme about it. Yes, that's perfectly right. Yep. There's this image which I love sharing every time if I talk about this. Let's say this baby is the data, right? TCP handles data very well, right? If there is communication happening between you and me, TCP is going to be like, for example, with the messages on like the chat, TCP will make sure the chat what I type versus what you type, right? Both reaches. But if you have done, like, let's say WhatsApp call, right? If you ever done WhatsApp call, the connection is not the best. Certain parts just vanish, right? You won't even know, and you can't get them back. They have vanished, right? There's so many more things about it, right? For example, let's say if the connection is bad, like all things go at same time. Though, and not that there is, like, with video calls, it's always UDP or it's always TCP, depending on which software you're using. For video calls, like for example with Twitch, I think they might be using TCP at the background, right? But for WhatsApp, they are using UDP. So different softwares, you can achieve same or you can, for same type of service, you can implement either TCP or UDP. It's just what do you care about more, right? Or what type of service you want to provide. For example, emails, you want to make sure every single person you send the email goes through TCP. So you will hardly see a computer, a software that would use UDP for email. You will hardly ever see this because it won't be a successful one. Does that make sense? Like that, for data, both can provide the same type of service, but like it's just sometimes it's better to use one compared to the other. So UDP allows us to reach a specific process on this target host. UDP is a simple connectionless protocol, right? There is no connection properly set up. Let's say if I'm doing video call to you guys, really, I don't think so. I don't think so. Is UDP faster? Is UDP? Oh, it's generally faster. Like if there is no connection, error checking and stuff. Okay, yeah, makes sense. When is TCP faster than UDP? Let's see. Okay, so basically because of the extra processes or extra checks, TCP becomes slower, but it can be faster if things are like in small packets. But there is no like really like, does anybody TCP versus UDP performance? The most important thing TCP gives you is the congestion. There is a lot of, like, I think that this is a good point, right? So what this person is saying. So to answer your question, Sriram, so thank you. First of all, I didn't know it too, right? But there is another like really good point. This guy in because there is no, how to say it, faster UDP just in terms of speed. Sure, UDP is faster, yes, but then there is like the idea is UDP. Let's say if there are two races, right? Two things are happening. If you remember the rabbit and the turtle. This race, right? If you remember, imagine, right? If let's say turtle is TCP, your range, what's up, homie? Right, so like the reason of fast process, right? The idea, the question, at least I would have, right, is that with rabbit, right, versus turtle might be slow, right? It might be slow, but at the end of the day, it finished the race, right? It finished the race, reached. Whereas with the rabbit, what if it never reached? Even though it was faster, it never reached. So there is that thing. In general, if they are reaching, yes, UDP is faster. but there is it's hard to say because UDP can be dropped at the middle of the day, whereas TCP will reach at the end. Hopefully that answers it, not exactly the way you want it, because there's like other things right in place. And I think this is a good one. This is a good one. UDP versus TCP. The guy brings out some really good points. Sweet. Thank you, man. That's a good question. So, UDP is simple connectionless protocol that operates at transport layer, the layer 4. Being connectionless means that it does not need to establish a connection. UDP does not even provide a mechanism to know that the packet has been delivered. An IP address identifies the host, right? For example, I want to give you a WhatsApp call, right? We need a mechanism to determine the sending and receiving process. This can be achieved using the port number. So port number uses two octets consecutively. It means between 1 and 65535 port 0 is reserved the number. So basically, to explain to the people what ports are, right? Let me give you a simple example. Let's say this is your guy's computer, right? This is your PC. In your PC or in your laptop, there are a couple of ports like the USB port, USB-C port, there is HDMI port, there can be another USB-C port, right? There are multiple ports. These are actually called physical ports. Yeah, no, I don't think so, bro. Nah, I think he might be just grabbing water, bro. So there are physical ports, right? Yeah, probably. There are physical mode, right? Physical port. Physical ports are basically the one you can interact with. But as you know, in computer, there is just like there is physical like things you can touch in a computer, but you can't touch, let's say, a software, right? So there are just like you can't touch a software, a website. You can touch a monitor, right? That's the same thing. There are some networking ports which non-physical ports. See, I told you. There are non-physical ports which are actually your motherboard and your network interface got. And how many are there? There are total 65536 total number of ports, but available are -1, so 65535. So 1 to 65535, which is 2 raised to the power minus 1. 2 raised to power 16 minus 1. Right? So there is physical ports. Remember, there is physical ports, the one you can touch. Then there are non-physical ports that are inside your networking interface. And important know from a cybersecurity point, right? There are like every single a majority of the ports, right? For example, if you know port 22, it will there are bunch of ports which are very important to memorize, and because they have a very specific purpose. For example, in your house, right, there are so many doors, but there is one specific door that is called the main door where people come in and out of, right? There could be some back door where, let's say, for example, in a big building or in a restaurant, there would be a main door where customers come in. There is a back door where some employees can come and go in, and there might be a delivery door where only the big trucks for supply can come, right? So bunch of ports And there are some general doors, right? Anybody from the hotel is coming in, whatever. So though there are certain ports which are very specific in Purser, yeah, they have dedicated for certain purposes like SSH, HTTP, HTTPS. All these are have ports, right? 443. Other ones you guys have to just wanted to let you know, right? What ports are, because I didn't get the meaning of ports. I had to like understand. Yeah, there are 65535, 65,535. That's the maximum reaches. Total are 65,536. Yeah, default ports. A real life example similar to UDP is the standard mail service with no delivery confirmation. In other words, there is no guarantee that the UDP packet has been received successfully, similar to the case of sending a parcel using standard mail with no confirmation of delivery. In this case of standard mail, it means a cheaper cost than the mail delivery options with the confirmation. In the case of UDP, it means better speed than a transport protocol that provides confirmation. Yo, you got the answer here, I guess. That's amazing. Good. So in standard mail, right, I send a package to someone. I send a gift, Christmas gift card, right, to you guys. There is no way for me to know unless until I actually ask you again through a proper channel. In the case of UDP, it means better speed than a transport because there is no confirmation in UDP. But what if you want to if you want a transport protocol that acknowledges received packets? The answer lies in using TCP instead of UDP. TCP, Transmission Control Protocol, is a connection oriented transport protocol. It uses various mechanisms to ensure reliable data delivery sent by the different processes on the networked host. So connection oriented, main purpose to make sure the connection is there, like the two hosts that are in connection or that are communicating. The packet from me is going to you, just like in YouTube, and whatever you send, for example, through chat, I'm getting it, right? That's what TCP is. Like UDP, it is a layer 4 protocol. Being connection oriented, it requires the establishment of a TCP connection before any data can be sent. What does that mean, right? Is that, let's say this is me, CH, and let's say this is you guys. Right? So what does means in TCP, right? My this is my computer, this is your computer. Before a communication, before I can send you a message, before you guys can see my stream, before anything like that happens, a proper connection is established for a proper was let's say for example, let's say this is your house, right? Let's say this is your house, right? You want to receive water or you want to receive electricity. What needs to be done first? A proper connection from, let's say, if this is the city, right? A proper connection of water pipe needs to go to your house. There should be a connection, a proper connection of water to need to happen at your house before you can get water, right? Same thing here. They can't just like throw water in the air, right? Like to give you. Same thing here. A proper connection needs to happen first, and that's called a three-way handshake. This connection needs to happen first, in which My computer says, hey, I want to send you a request. Your computer like, okay, I will start accepting the request. You can send it to me now. My computer will say, okay, I'm going to send now. Simple. Three-way handshake, three messages are sent. In TCP, each data octet has a sequence number. Yes, sir, exactly. Yes, sync and acknowledge, and then acknowledge. Each data octet has sequence number. This makes it easy for the receiver to identify lost and duplicate packets. The receiver, on the other hand, acknowledges the reception. You're over. Howdy, bro. The receiver, on the other hand, acknowledges the reception of data with an acknowledgement number specifying the last received octet. What this means, right? The connection we are establishing. What? No, like basics are saying acknowledge and stuff. So receiver is like my host, right? The receiver on the other hand acknowledges that. Basically, let's talk about this. I will draw this image and help you understand what this is in a better way. A TCP connection is established using what's called a three-way handshake. Two flags are used: sync, acknowledge. The packets are sent as follows. Sync packet, the client identifies the connection by sending a sync packet to the server. This packet contains client's randomly chosen initial sequence number. If you go in more detail, there are more. Oh, okay. Yeah, only three, but like a lot more detail about how the handshake happens. So sync packet, right? First, my host will send a sync packet to you guys. Sync and acknowledge packet. The server responds with sync packet to the sync packet with a sync and acknowledge packet, which adds the initial sequence number randomly chosen by the server. So I will have a random value chosen. Let's say 3. Your system will send me another packet. Sync and acknowledge packet, and let's say you chose the number, let's say you chose the number 5. Sync packet, the three-way handshake is completed as the client sends an acknowledge packet to acknowledge. What now? I will give you a bit more detail what now is going on, how in a human way you can think about it, right? But there is now just acknowledge. My computer says to you guys, hey, I want to start a connection with you. This is my random byte sequence number. Your computer says, okay, we are ready to establish the connection. I sent, what's this called? Your host will send me the message saying, okay, we are ready to establish the connection, right? And we acknowledge that you want to. Okay, we are ready to accept it. My computer then will say, okay, acknowledge that you are ready, right? Simple. Sync, async, and this is how when you talk to Facebook, when you talk to YouTube, me, that's the whole connection. What protocols are available and accepted for the connection? Is it? Yes. What type of what connection? TCP basically, and what all things I will be sending. Like for example, HTTPS, FTP, all those stuff. Those extra information is also there. What type of connection, like inside, what I will be doing. When I do go to HTTPS Facebook.com, right? So like inside this is like the TCP. This is main. This is TCP. Like this, all the green packets are the protocol they are using is this TCP. Similar to UDP and TCP. Does that answer your question? Like basically, you're asking what protocol is used when this during this communication, right? The main protocol is the TCP one. There are other protocols inside the sync one, like the IP protocol, right? For the address. There is HTTPS, couple of other things happening. Yeah. But mainly, if you talk about just this process, this thing, that's TCP. Yes. Now, you were having the conversation, and I was saying during that I want to connect. You were having the conversation, and I was saying during that I want to connect talk. They also decide. Yeah, yeah, like what will be the best protocol? Yeah, I think. Wait, I need to understand. Nah, you were having the conversation, right? I'm saying during that. Oh, okay. And there's nothing missing, right? Like, yeah, yeah, yeah. Nmap does those because then you can in Nmap you can tell if you want a UDP connection, you want to send UDP packets or TCP packets. You can do that. Okay. Thank you, Robert. So similar to UDP and similar to UDP, TCP identifies the process of initiating or waiting for a connection, right? Using a port number. As stated, a valid port number ranges one between 1 and 65535 because it uses two octets. One octet is 8 bits, so 2 to the power 16. 2 bytes, we need 2 octets. 8 plus 8, 16. 2 raised to power 16 minus 1 because port 0 is reserved. So 65535. Now, what protocol requires a three-way handshake? What is the approximate number of port number in thousand? You guys have to answer this, lads. TCP, yes, sir. 65, yes. Awesome. So, let's get into the encapsulation. Before wrapping up, it is crucial to explain another key concept called encapsulation. In this context, encapsulation refers to the process of every layer adding a header and sometimes a trailer to receive unit of data and sending the encapsulated unit of layer below, right? Encapsulation is an essential concept as it allows each layer to focus on its intended functions. In the image below, we have the following four steps. So I will explain to you. I have a really good uh, way to explain this. Application data. It it all starts when the user inputs the data they want to send into the application, right? For example, you write an email or an instant message and hit the send button. The application formats that data, starts sending it according to the application protocol used during the layer below it, the transport layer. Now, let's do a quick thing for easy. Do I have that? No. I want to show you guys do it in a proper way. right? Let's say we have this a we are using TCP IP model. Okay. Now, it all starts with the user input, right? So let's say a packet is created at this level. I wish I could crop it. Crop image. Nice. Okay, awesome. So it starts with application data, right? And every single layer has its own like protocols, but it all starts, let's say, here. The data. This is the data you want to send. It went to the application layer, right? It goes to the application layer. So application layer will have some header. Let's say HA for application layer header, and the data you sent it before. Okay, so that for example, you write an email, instant message, hit the application, formats this data, and start sending it according to the application protocol used. Transport protocol segment or datagram. The transport layer, such as TCP and or UDP, adds proper header information and creates a TCP segment or UDP datagram. For TCP segment, UDP's datagram. We'll talk about segment. It's easy. We're just one, but you guys will get the idea. This segment sends to the layer below it, the network layer. So what now happens is it's cool we have the same colors in this. This data from application layer now a bigger it becomes a bigger packet. Now it has a header or extra information from transport layer, and that's all the data it has. Same thing now we'll have with the network layer. The network layer, that is the internet layer, adds a IP header to receive TCP segments or UDP datagram. Then its IP packet is sent to the layer below it. Right? So again, the same process. Say let's keep it white this time. Not the best thing to say on the internet. So we will have header for the internet layer, right? This, whether it's with transport layer, internet layer, it will add like its checksums, its protocols. This header contains that extra information about protocols and stuff. And here, oh, now let's quickly do this guy. Well, I'm getting 20 billion notifications. Then we have a header from this layer, network layer. So this is how when you send the data like your email, this is how layers are being put, right? For example, when I'm trying to talk to you guys, this is how it happens. This is my computer. So network data link frame. The Ethernet or Wi-Fi receives the IP packet and adds proper header and trailer, creating a frame. So this one will also have one extra thing compared to other ones, a trailer. Now, this is me. Now I will send it to you guys, right? Now what happens, just like we were putting the packets, I was wrapping my, let's say my data is like almost like a gift. I'm wrapping things up. When you receive it, you are going to unwrap this, right? So all this data, all this extra information, you first start with unwrapping this one. You remove the header and trailer. Your computer then removes this one, then this one, then this one, and you receive the data at the end. This is basically how the whole internet talks, how the whole world talks at this point. We start with the application data. At the transport layer, we add a TCP or UDP header to create a TCP segment or UDP datagram. Again, at network layer, we add proper IP header, get the IP packet, then we go to the internet, right? Routed over the internet. Finally, we add appropriate header and trailer for the Wi-Fi and data. So this is how from layer it starts top to bottom. This process has to be reversed on the receiving end until the application data is extracted. The packet of a life. Based on what we have studied so far, we can explain a simplified version of the packet's life. Let's consider the scenario where you search for a room on TryHackMe. On tryhackme.com search page, you enter the search query. Your browser using HTTPS application layer protocol receives a HTTP request and pushes it to the layer below it. The TCP packet needs to establish a connection via three-way handshake between your browser and TryHackMe's web server. After establishing the TCP connection, it can send HTTP requests containing search query. So we searched something, we entered, right? Now a connection between me and TryHackMe will happen. TryHackMe servers will happen, right? Based on my search query. Each TCP segment created is sent to the layer below. The TCP layer adds the source IP address, right? So for the where I want, right, my computer, that connection, that information, and TryHackMe's web server, right, or like their IP or basically their URL, mostly their IP, also is in there. This here, the transport layer, this layer has the IP addresses of the source and destination. For this packet to reach the router, your laptop delivers it to the layer below it. This guy, internet one. Depending on the protocol, the link layer adds the proper link layer header and trailer. So depending on what protocol, like Ethernet, Wi-Fi, what one, which one? Excuse me. The router removes the data link layer header and trailer, inspects the IP destination, among other fields. So the router now gets this header. It will take care of all the other things. Okay, where to send it, what to do, blah blah blah. The steps will be reversed as the packet reaches the router of the destination network as we cover additional protocols. So what happens is, when this packet, this white one, reaches your router, or actually this one, right? This is the network one, right? MAC addresses are removed, and the white one, where it's like the other information needed. For example, the TCP one, I believe. No, it's the blue one. Actually, these ones are removed. The blue one with the IP addresses. That's what your what's the name, router takes care of, right? On a Wi-Fi, within what will okay. On a Wi-Fi, within what will an IP packet be encapsulated? These are the questions you guys have to answer, lads. So this is asking fragment, packet, what the answer would be for here. What is the answer for on a Wi-Fi? Within what will an IP packet be encapsulated? So, what is the name of this like green thing? Are you sure? Okay. So for layer, what is saying on Wi-Fi? Wi-Fi is the data link layer, right? So it will be a frame. Wi-Fi receives the IP packets, adds a proper header and trailer, making it a frame. For a TCP, it will be segment, UDP datagram. So that's like it's just, and then basically for network layer, TCP and UDP, if they're asking these, but for if it was layer four, this 3, the network layer, then yes, it would be packet. But for this one, it is a frame. Yeah. You got it, bro. What do we call the UDP data unit that encapsulates the application data? What is this one? So yeah, frame and frame for layer 2. Yeah. So packet for layer 3 if they're asking about IP, but for if they're asking UDP, it's datagram. I don't remember much about datagram segments. I just need to I have a good understanding of how this packaging and unpackaging happen, and that's what like I think does help big time. Okay, now we have a start machine. Thank you, Range. Thank you, Shiram. Okay. So, we're doing free ad. Did I? Start the machine. Okay. Oh, this. No. This was like a way before I used to work for this company. It's not even in Canada anymore. Yeah, it does say something. Oh, never mind. Don't worry about this company. It's not even in Canada anymore. It was okay company. Hide the IP, I guess so. Okay, so this is the last one. Let's get it done because I have work starting in like 4 or 5 minutes. So start the attack box by pressing the start attack box button at the top, blah blah blah. Give 2 minutes. Okay, once the two machines are ready, we need to start the terminal on the attack box to experiment the telnet, right? So I have to start mine too. Can't do anything. So Telnet protocol is a network protocol for remote terminal connection. In simpler words, Telnet, a Telnet client allows you to connect to and communicate with a remote system and issue text commands. Although initially it was used for remote administration, we can use Telnet to connect to any server listening to to a TCP port number. On the target virtual machine, different services are running. We will experiment with 3 of them. Echo server. This server echoes everything you send it by default. It listens to port 7. Daytime server. This server listens on port 13. By default replies with the current day and time. And HTTP server. This server listens to on port 80 by default and serve web pages. So we have using Telnet, right, which is a simple protocol that will you can use to establish a connection between any remote server. Echo server, daytime server, and web server. Before continuing, we should mention that the echo and daytime server are considered security risk and should not be run. However, we started them explicitly to demonstrate the communication between server using Telnet. So don't use those servers. They're just so you can these are just so that you can talk to see how Telnet works basically. In the terminal below, we connect to the target virtual machine at the echo server on port 7. So we have Telnet. This is our IP and the port number. So Telnet command, IP, and the port number. So if we do the same, echo 1 will repeat whatever we say, right? So if I say hello, it will say hello. If I say Shriram, Range, Rover, right? Subscribe, hack, I think that's better. So it will repeat whatever we say. Maybe we can break it by sending, let's say, some code or something. Or just like some Unicode. I don't want to try it actually right now. Nope. Okay, we have to use the so this is we exited Telnet like the previous connection, but if we say hello now, it still is doing the same. Tell, okay. Now I have to do it. No. Oh, now I do exit. Close. Okay. Looks at, oh, yeah, actually, what happened, Wrench? Remember, I was saying on the weekend, like I was trying to add you as a approved. So please don't use the any of the words. Nothing will get censored for you, I believe. You can even send the URLs and stuff. So that just make sure don't send anything. You are part of the approved list now. So yeah, congrats. So we have Telnet 7, so it repeats whatever we say. Oh, we have quit as well. Okay, that's the word. In the terminal below, we have the daytime server on port 13. Why? You guys don't have to start saying that. You don't have to start saying that. Yo, I have to go back to this. Okay, never mind. It's part of the Telnet 13. No, not everyone. Actually, there is like only 5 people, I believe. So here we got daytime from our daytime server. Now let's start with the last and the fun one. Bro, I now I'm I don't know what to say. Okay, so we have the 13 one. Now for 80, right? We connected to the server, but we need to tell him like, hey, we want the HTTP page on the root directory. So we'll say get the root directory with http1 host telnet.thn. That's the name of the server we need to talk to. So we did that and we got 400 bad requests. 400 bad requests. Hey, at least it talked. So if I say get slash http 1.1, that's a very old one too. Host telnet. Let's see what will happen. Oh, okay. We got our flag this time. Last time, because of this extra space, we didn't. So this is great. So you guys, I'm the king. You guys have power. Nah, I'm not doing that range right now. Okay. With that being said, right, use Telnet to connect to the web server. What is the name and the version of the HTTP server? Let's see. 1.1. Name of the HTTP server? Oh, the light HTTP 1. Yes. This is what it's using. Let's go. And our flag being telnet master. Conclusion. In this room, we covered the ISO OSI and TCP IP model, comparing and contrasting the two. We also covered IP addresses and subnets, briefly explaining routing. Furthermore, after diving into TCP and UDP, we explained encapsulation. For demonstration purposes, we used Telnet to talk to the different servers over TCP. Now that we have finished networking concept, it is time to join networking essentials from tomorrow. Please note and remember all the concepts. I'll try to remember. All good. Yo, this is the first room with the new stuff. Nice. Okay. Oh, I like this image. Yeah, boy. Okay, so from tomorrow, we will start working on this premium room, networking essentials. So we have the introduction, DHCP, something you use, ARP, something is very important, ICMP again important, routing and NAT. Okay, all are important concepts then. Like in this one, this will be fun. Alrighty, lads. Sorry, you you saw me yawning couple of times. I just slept around 1 a.m. my time. Been studying this stupid software for so long. For so long. There's Alpine.js I've been studying. There is a local server I made of this goody good guy, Adobe Experience Manager, and I'm like really, really tired. Sorry, Robert. I'll try to close next from tomorrow, before tomorrow's stream or tonight's stream. I'll try to have at least some windows closed. Sorry, man. It's just because of this thing. Yeah, he would. He would. It's just because of this thing. I have like 3, 4 windows open because on left I'm doing something, on right I'm reading something. Is because of this specific thing, man. And you know, like if you actually see, I have a somehow just a version, but if you see AEM, right, Adobe Experience Manager, It's a content management system. It's like almost like WordPress. But do you want to see the price? Do you want to guess what would be the price of this yearly? Do you know the price? Ever thought of it? Zero. I believe last time I checked here, licensing starts at $30,000 per year. And so some of its extra plugins can make it go to $60,000 or $80,000 total annually, just the software licensing. Cheers. Enjoy. So this was your favorite censored hacker leaving you with some trauma to deal with, like how expensive this software is. Uh, and what I was doing for last 2 days was just learning this thing. I'm still learning. Yeah. It's nice in its ways. It's really like I will say this content management system, right? You can majority of so many big companies, so many big companies use it, but there are very few developers of it compared to like other things. So yeah, that's why piracy is a thing, man. That is why. This is how it is for me. The good old admin. I didn't set up that password. So this is how things look, right? It's all like this, I believe. So I can change, drag and drop things, which is, I think, now a lot. But these experiences, you will get so much data it collects because it's a Adobe one. Yeah, no, hopefully not, right? But like this one has like so many extra features. It's crazy. Like Adobe Experience Manager comes with these ones, right? Analytics, Audience Manager. So let's say if you go to a website, right, and if they already have a profile about you, they based on what they have information, they will either open a men or a women one automatically. So the website will change according to who you are. It can change based on your location, based on the language, based on your gender. So much data it collects about you that it can give you experience like Amazon, right? It gives you the what's this called? The products you might be interested in. This one can like change any website it is being used for in ways who you are. Yeah, almost. It can probably will read our mind because Adobe, man, it's Adobe. It can target so many. It's like e-commerce. It is like very heavy duty work. It will yeah, probably. But yeah, that's just wanted to show you like what I was doing from last 2 days and what I had to deal with. You see, you see, it's all purple. So many pages will be just purple. Okay, so but that's it for today, lads. Hope you guys enjoyed it. Right? Hope there was some fun we had, and some good learning. Tomorrow I will see you guys around this time for Try Hack Me, and in the evening, hopefully, for some lead code. Yeah, probably. Yeah, go for it, man. A lot of people call me G. Same thing. Don't be G, bro. Okay, but this is your favorite censored hacker signing off to sniff some networking packets and go do some slavery. Till then, thank you so much, and I will see you guys tomorrow. Till then, bye! Bye, everyone. Thank you so much for joining. Love you, love you, love you, love you, love you, love you, love you. Have a nice day. Have a good night, and peace out.